In this video we'll go through what's commonly known as testing pyramid, which are various types of tests your application might need, explain their role, and go through examples on our Spring application. Sample application we'll use enables users to register or sign in via Google or GitHub. Application is simple enough, but also has multiple layers to effectively showcase different types of tests. If you're not familiar with what testing is or what assertions and mocking are, I suggest you have a look at the introductory video I made on the topic before you continue with this one. Let's look at a broad overview of what our app architecture looks like, so we are on the same page. We are receiving HTTP requests from our clients that proliferate from our controllers to our service layer, and we use repositories to save data to a relational database. We are also securing our requests. Embedded Tomcat Web Servlet container processes HTTP requests using a series of filters. Spring provides filter implementation named Delegating Filter Proxy that allows bridging between servlet container lifecycle and Spring application context. Spring security is contained within filter chain proxy that uses its own filter chain, security filter chain, that determines which security filters should be involved for the current requests. If we pass through security checks, we can access our pages. Spring MVC, the web framework we use, is designed around front controller pattern, where a central servlet, dispatcher servlet, provides a shared algorithm for request processing. Actual work is performed by configurable delegate controller handler components. We'll explain a little later all the responsibilities controllers bear in Spring applications, but they should contain little to no business logic. That's the purpose of services, to which our controllers delegate the real work for request processing to. One of the things our service does is uses repositories as abstraction over persistence layer to save users to relational database. I'll point out that controllers, services, and repositories are just normal classes. What makes them special in Spring are stereotype annotations with which they are annotated with. They tell Spring to make instances of them, so-called beans, auto-wire their dependencies and construct coherent application context, a container populated with our beans. Now that we have a broad overview of the architecture of our system, let's talk about testing. We mentioned that our beans are just plain Java classes, but we have an even better example, a toast class that doesn't have any annotations and it's not related to Spring at all. Perfect example for the first unit test. Purpose of unit tests is to test a unit of work. Could be a single method or a method that is composed of multiple private methods. What we could test in an example of our toast class is that our static factory method success, warning, and error create proper instances with the appropriate title, message, and class properties. Let's create a test class for our toast example, which we can do in IntelliJ by pressing Ctrl-Shift-T. This will create a class in a test folder mirroring the package structure of our original class. We can create our first test. Should create proper instance. Our toast will be toast success, title will be test, and the message will be test message. And then we can assert that all, because we'll test on multiple fields, we'll assert that our title should be, so our title should be test, that will be our toast title. Our message should be test message. And our class should be success. So we'll assert that success is our toast class. And we can save it and run our test. And our test passes, and we see that it ran in 31 milliseconds, so it was really fast. It was fast because all objects needed for test are created in memory. And the way we ensure that our unit tests are fast are by avoiding operations that are inherently slow and costly. which are input-output operations, think network or database access. Our toast class is just a normal class. It didn't have anything to do with Spring. Let's see how we would unit test our service. Our app user service, which is annotated with Spring stereotype @service annotation. If we analyze the dependencies of our app user service, we'll notice that two of the dependencies are repositories. And we don't want to inject and use real implementations because it would transitively require us to spin up a database, which we said was a slow input-output operation. Instead, for our test, we'll mock our repositories, which will give us the opportunity to control their behavior. And we are interested in testing the simplest method that exists in our app user service, which is user_exists method, which only delegates to user entity repository to check does the user exist by username. Let's create our test. We'll create a new test class, and we don't want to annotate it with any of the Spring's annotations because that would raise application context. But we want to use mocks, so we'll extend our class with Mockito extension class. And we want to mock our user entity repository. And in our app user service, we want to inject the mock. So we'll say inject mocks. And then we'll create a test class, a test method, sorry. Should return true for existing user. And we'll use mocks to model the behavior of our user entity repository. Let's write our test. We'll use Mockito when method to model the behavior of our user entity repository. And we'll say when our user entity repository exists by ID test is called, then our user entity repository should return true. And then first we can write a failing test. We'll assert false that when our app user service with user_exists test is called, that our app user service should return false. We'll run the test. The test should fail. Expected false, actual true. And then we'll make our test pass. That's just to make sure that test is wired up correctly. And the another thing we can do is verify that our mock was called. We'll do that with Mockito verify method, and we'll say that our user entity repository, let's also create a failing test first. We'll say that find by ID method should have been called. Let's run our test. And we see that wanted but not invoked find by ID. And what was invoked was exist by ID, so we'll make the test pass again. And there we have it, a green test. We modeled the behavior of our user entity repository, kept everything in memory. We didn't use any Spring's classes to raise Spring application context, and we didn't raise real database infrastructure. That's why our unit test runs fast. This test seems trivial and it tests the explicit behavior of our method. But unit test also gives us the opportunity to think about the implicit behavior of our method. What should happen when our user entity repository throws an exception? How should our class behave, our app user service class? Should it catch some exception, propagate it, or translate it to something that has a business meaning? That is a question you have to answer on class by class and method by method basics. In our case, we might conclude we'll just propagate the exception and let the callers of our service deal with it. That's already the implicit behavior of our method, but we may put it into test to make it explicit to someone else who's examining our code. So let's create a new test. User_exists should propagate exception, and we'll say this time for our mocks, when our user entity repository is called with exists by ID with any string, we don't care, then we'll throw username not found exception class, and we'll assert that our app user service should throw the same exception, so username not found exception when its method is being called. So our app user service user exists. So our app user service user exists method should throw the same exception as our user entity repository. And then we can also verify that our user entity repository exists by ID was called. And we'll run our tests. And the test passes. In this case, we didn't go to the whole cycle, make the test fail, then make the test pass, just to save some time. But in real life, in your projects, you should do that, just to make the sanity check that your tests does indeed what you expect it to do. Traditional testing paradigm was that you should have the largest number of unit tests, since they are cheap and run fast. This is illustrated in our pyramid as well. A step above unit tests in our testing pyramid are integration tests. Generally speaking, they verify that different modules or components of your application work well together, so they imply communication between components we want to test. But more specifically in the Spring ecosystem, it also implies instantiating Spring container and providing dependency injection or test fixture instances, providing transaction management and supplying Spring-specific base classes. So integration test comes with the cost of spinning up required infrastructure and are slower than unit tests, sometimes a lot slower, by a factor of 100 or more. I've mentioned that traditional testing paradigm suggests that the number of your unit tests should be by a factor greater than the number of your integration tests. However, what you find is that with the rise of microservices architecture, the whole point of your application might be to transform data using other services. And in fact, even our web app does not have some fancy algorithm. If you'll boil it down, it just transforms HTTP requests to HTML and uses simple functionality internally to do so. To closely reflect the functionality the app provides, we might increase the number of integration tests and reduce the number of explicit unit tests. Notice we'll call our class methods with integration tests too, so we'll be performing pseudo unit tests with our integration tests as well. Our testing stack then more looks like a honeycomb than a pyramid. You may ask yourself, if integration tests are about interaction between components, isn't that what we were doing in our app user service when we were mocking repository our service communicates with? Why did I say we were writing unit test and not integration test? A unit test covers a single unit, where a unit is commonly a single class, but can also be a cluster of cohesive classes that is tested in combination. Don't let repository in our class name confuse you. What's important in our app user service test is that we were creating object graph needed for the test manually. We didn't fire Spring's application context, so in our test case, user entity repository is not a class that serves as a persistence provider and represents different layer than our service. It's just a collaborated through our main class that together represents a cohesive unit. Therefore, it's a unit test. If we get back to our application architecture, what would integration test entail? A test that covers multiple units. It tests the interaction between two or more clusters of cohesive classes. For instance, all controllers, all repositories. And it's an integration test because we'll test communication between those beans and Spring's application context. Secondly, a test that covers multiple layers, for example, interaction between a business service and a persistence layer, or interaction between a persistence layer and a real database. If you're interested in this particular scenario, I've covered that in a separate video you can check out. We could also test the whole path through the application. In these tests, we send a request to the application and check that it responds correctly and has changed database state according to our expectation. Spring provides @SpringBoot test annotation for this purpose. I'll note that with @SpringBoot test annotation we can create context that includes real servlet environment or just mocks one. The difference is controlled by web environment property of the annotation. If we request mock web environment, which is default, mock servlet environment is provided. But if we request random or defined port, real servlet environment is started, in our case embedded Tomcat. To facilitate cluster of related classes tests, Spring offers so-called slice annotations. For instance, add webMVC test will by default load all controllers in context. We are using JPA and relational database, so add data JPA test would load all entities and repositories in context. If we were using MongoDB, there's add data Mongo test, for Redis, add data Redis test, etc. I specifically want to return to controllers and explore their role in Spring application and the difference between unit and integration tests for them. Controllers have 6 responsibilities in Spring application. They need to listen for HTTP requests, deserialize the input, validate the input, call the business logic, serialize the output, and then translate exceptions if there is any. In unit test, we would test the controller in isolation. In integration test, we would fire up Spring application context that contains mock or real servlet environment. Let's go to our app user controller and look at responsibilities one by one. Do we listen for HTTP requests in unit test? No, because unit test would not evaluate post mapping and similar annotations specifying the properties of HTTP requests. We need a servlet environment for that. Do we deserialize the input in unit test? No, because annotations like request param or add path variable would not be evaluated. Instead, we would provide input as Java objects, effectively skipping the serialization from an HTTP request. Are we validating the input on unit test? Not when depending on bean validation, because add valid annotations would not be evaluated. Are we calling business logic in unit tests? Yes, because we can verify if the mocked business logic has been called with the expected arguments. Are we serializing the output in unit tests? No, because we can only verify the Java version of the output, and not the HTTP response that would be generated. Are we translating exceptions in unit tests? No. We could check if a certain exception was raised, but not that it was translated to a certain JSON response or HTML error page. In summary, a simple unit test will not cover the HTTP layer, so unit testing controllers serves little to no purpose, as it does not cover any of the main responsibilities it has in our application. If we want to test them, we'll need to use integration tests and fire up application context with add webMVC test or add Spring Boot test annotations. Add webMVC test slice annotation will set up our application context with just enough components and configuration required for our web controller layer. For instance, it will set up our controllers, but not services, repositories, or our own security configuration. If we need any of those objects, we need to add import them or mock them away with add mock bean. One thing add webMVC test annotation will provide for us is Spring MVC test framework, also known as mock MVC. It can perform full Spring MVC request handling, but via mock request and response objects instead of running server. Let's look at the example of integration test class annotated with add webMVC test annotation. We use mock MVC testing framework to perform mock requests and make assertions on mock response objects. We are interested in using our real security configuration, so we are importing it with @import. We are mocking away our app user service class our controller depends on. @webMVC test annotation can take controller class as a parameter, in which case we are telling Spring Boot to restrict application context created for this test to a given controller bean, plus some framework beans needed for Spring MVC test, like mock MVC. All other beans need to be included separately or mocked away with @mock bean. If we leave away controller parameters, Spring Boot will include all controllers in the application context. Thus we need to include or mock away all beans any controller depends on. This makes for much more complex test setup with more dependencies, but saves runtime since all controller tests can reuse the same application context. Test mantra is to make tests isolated and independent, so I prefer narrowest application context, even though Spring Boot will have to create new application context for each single test, making the whole test suite slower to execute. Let's briefly return to our application to remind ourselves of the functionality we'd like to test next. We have a sign up button that leads us to a sign up form where we can sign up with our, let's say, new user. This leads us to a login page and gives us a toast message that a new user was created. On the login page, we can use the newly created users to log into our application, which leads us to the users page. If we log out and try to sign up with the same user, we should receive an error message that the user already exists. Previously, we've tested our controller using @webmvc test. Let's create a new test that will spin up a real database and use mock-mvc to test sign-up functionality. We'll use @spring-boot test annotation for that. Let's go back to our application. We already have app-user-controller test that uses @webmvc test annotation. We'd like to create a new test class. If we look at our app-user-controller, we'll see that the sign-up functionality uses a post mapping to user sign-up and uses a sign-up form which has two fields, username and password. If the sign-up is successful, it gives us a flash attribute of toast and a class of success with a message that user was signed up, otherwise it gives an error. So let's create a new test class that will annotate with @spring-boot test. We'll call it app-user-controller integration test. And we'll annotate it with @spring-boot test. We also need to use a real database, so we'll mark our class with active profile Postgres, which spins up a real database using test containers. And now we'll auto-wire our mock-mvc, with which we can perform our post request and create a new test method. Users can sign up. At this point, our Spring Boot test would fail because we can't auto-wire mock-mvc as it's not included by default in Spring Boot test as it is in our WebMVC test. If we drill down into WebMVC test, we'll see that it has auto-configure mock-mvc. So we'll need to add the annotation to our Spring Boot test class as well. We'll actually want to test the state of our system, so we'll auto-wire our app user service and our app user service and our user entity repository as well. And we can assert first that the user should not exist when we start this method. So we'll say that in our user entity repository, exists by ID user test should not exist. And similarly for our app user service, user exists test should return false. And now we can use our mock-mvc to perform our post request. The endpoint is user sign up. And we expect that the status is redirection, and we should redirect to /login. And we'll need to pass in the form parameters. So we'll say that the username is test, and then the password is test password. Spring expects valid CSRF token, cross-site request forgery token for our post request, so this request would not work because mock-mvc doesn't include it by default, as it wants to give us the ability to test invalid requests. So we'll need to include CSRF token in our post request. We can do that by using with method and passing in the CSRF token. Another useful utility Spring offers is printing out all the values from our request and response, and we can do that by using do and then print static method. We also saw we get a toast success message when we successfully sign in, so we can make assertions based on that as well. And toast is passed as a flash attribute. So to make assertions based on flash attributes, we'll use and expect and say flash. And first we can say that the attribute of toast should exist. And we can also make assertions on the value of the class of the toast attribute, because we may get an error toast as well in the case user already exists. So we'll say attribute toast, and we can pass in the result matcher as the second parameter to compare values. And I've created toast feature matcher, which enables us to extract class field from our toast. So we can use that. We'll say class import static method from our toast feature matcher, and we say that the class is success. And then we can copy our assertions on the beginning of the method and change them to be true. Another thing we'll need to do, since we are using a real database, is we'll need to roll back every method so it doesn't trample on other methods' data. And we do that by annotating our class with @transactional. It's configured in the context of test to roll back every method. So let's do that. And now we can run our test. And success. Nice. Let's discuss what are functional tests, which are next in our testing pyramid. Functional tests are an ambiguous term. What I mean here are tests that focuses on the result of processing and not the mechanics of the processing, and determines whether the application satisfies the basic user's expectation. In that sense, functional testing definition is near synonymous with black box testing, where in our previous integration test we were checking content of database and verifying communication between our components. In functional tests we are not interested in internals. Instead, we are performing actions allowed to end users, and testing we get what the user expects to get. The top of the pyramid, end-to-end tests, actually is not a specific type of tests. It's just the edge case of functional tests, where we spin up the whole infrastructure and maybe use additional testing techniques like recording videos of our user interface tests. To perform functional tests, we need to introduce additional automation tools that are able to interact with the user interface of the application under test. They can identify objects on screen, such as input text boxes. Buttons can make selections, enter data, and press buttons. These actions can be defined and replayed to replicate users' activity. The results of these actions are noted by the testing tool and compared to the expected results to determine whether the test passed or failed. We'll introduce these tools in the follow-up session, but for now let's look at an example of test that uses one of these tools, HTML unit, and see how we would implement user sign-in functionality and then login test. In our previous test we've used mock MVC to perform request. This time we'll spin up real servlet environment. To enable functional testing, I've added additional dependency to our POM.xml, HTML unit. It's a headless browser that will enable us to interact with the HTML page. We'll discuss it in more detail in the next session. I've created additional app user control HTML unit browser test. And we spin up the real servlet environment by using web environment property of our add Spring Boot test annotation and giving it a value of random port. And then we get the port our framework gives us by using add local server port annotation. Let's start our test. We are using the web client, that's the HTML unit class that will enable us to interact with web pages. We are initializing it before class and closing it after. And literally we are fetching our user sign up page and we are searching elements on our page by ID. And for our user input we are setting the attribute of test, and for our user password we are setting the attribute of password test. And then we are searching for our submit button and clicking it. we make assertions that the resulting page we get should end with login, and then we can get the login page and search the user and password element on it and perform the login with newly created user. And we assert that if we do that successfully, we should be redirected to the user's page. And we see that our test was successful. What you may notice is that we raise the same infrastructure in our integration and functional test. And indeed, that's the case. The difference is, I repeat, the way we test. In functional tests, we take a black box approach. We test behavior of the system, and in integration test and unit test, we take the white box approach. We test internals. There is another type of test term, user acceptance tests, UAT, which seems to have similar meaning to functional tests. The difference is functional testing is a verification activity. Did we build a correctly working product? Does the software meet the business requirements? Acceptance testing is a validation activity. Did we build the right thing? Is that what the customer wants and is willing to use? For instance, if we had a sign-up form with 20 fields, it does satisfy business requirement in that the user can sign in, but it might fail user acceptance tests as it's too complicated to use. I've mentioned that functional testing is an ambiguous term. Another meaning it has is in functional versus non-functional tests, where functional testing isn't concerned with investigating performance, scalability, or reliability of the application. Rather, functional testing focuses on the result of processing and not the mechanics of processing and determines whether the application satisfies customer requirements. Non-functional testing concerns itself how well application performs. Does it satisfy customer expectations? In example, functional testing would be, can user sign in via login page? Non-functional testing would be, can login page be loaded in under a half a second? In that sense, our whole testing pyramid, even the functional part, belong under the broader functional testing. And examples of non-functional testing would be performance testing, usability testing, reliability testing, scalability testing, cross-browser testing, etc. We saw that Spring offers extensive and well-thought-out testing support for each of its sub-projects and the application as a whole. In the follow-up session, we'll introduce additional external tools needed for end-to-end testing. Until then, happy testing!